Start.
Good morning, students. I am Umesh Kumar, Department of Mathematics. Today, I will discuss about sets. What is set? If I write 1, 2, 3, 4, 5, these are natural numbers. First 5 natural numbers. And if I write these numbers in curly bracket, this has become a set. Okay. Now, what will be the definition of a set? Set is a well-defined collection of objects. What do you mean by well-defined? Let us take one example. If I write A, E, I, O, U, what are these? If I ask about these alphabets by anybody, everyone will tell these are the vowels of English alphabet. Okay? Now we will take another example. The collection of 10 best writer of Hindi. If I ask about these by other peoples, then the response will come different. Therefore, this collection is not well defined, and hence the set is a collection, a well defined collection of objects. Okay, we can take so many examples. If I write 1, 3, 5, 7, this is a collection of odd numbers less than or equal to 7. Okay, and this is a well defined collection, therefore this is a set. Okay, now how we represent the set? We can represent the set in two ways. Number one, roster form or tabular form. Number two, set builder form. Now see how we represent the set in roster form. Very simple. If we write all the elements or all the objects in curly bracket, for example 1, 2, 3, 4, this is called roster form, and we will give the name of set by using capital letters, and therefore I can write set A. Okay, we can write so many examples. We can take set B, A, B, C, D, like this. We can write all elements in bracket. This is called as roster form. Okay. Now second is set builder form. If I have a set A, E, I, O, U, can we write this in set builder form? Yes. How? Set A is written X such that X is a vowel of we have done? We have written a common property of these all elements, and that's why this is set builder form. Okay. Now let here A is an element of set A. Then how we write this? We can write this A belongs to A. This is the sign A belongs to A, and we read it as A belongs to set A. Okay. Now if B is not an element of A, we will write this B not belong to A. Okay. Now next is types of sets. Types of sets. First, empty set or null set or void set. What is empty set? A set A is said to be empty if it does not contain a single element, and it will be written as A equal to this. This is empty set. It does not contain any element, and there is a symbol of empty set. This is called as phi. We represent empty set by this symbol. This is phi. Okay. Second is singleton set. Singleton set. As it is clear by the name, single means one. Therefore, a set A is said to be singleton set if it contains only one element. We can write another example also. B equal to like this. These are singleton set. Okay. Next, third, equal sets. Two sets are said to be equal if they have same elements. For example, let we have two sets 1, 2, 3, 4. Another set is B 1, 2, 2, 4, 3, 3. Are these sets equal? We will see whether both the sets contain the same elements. Set A has 1, 2, 3, 4. 4 elements. But set B has 6 elements. When we write a set and its elements, generally we don't repeat the elements. Therefore, set B can be written as 1, 2, 3, 4. Okay. Now, if we see set A and set B, both are equal because both are having the same elements. Therefore, from here A equal to B. We can take another example. Let set A be A, B, C, D, E, and set B be B, C, A, E, D. Are they equal? Yes, set A and set B are equal. Why? Because set A and B are having same elements. The order doesn't mean here. Set A has A, B, C, D, E. Set B has A, B, C, D, E. And therefore, set A equal to set B. Okay? 4. Equivalent set. Two sets A and B. Let set A be 1, 2, 3, 4 and B be C, D, E, F. A and B are said to be equivalent set if they have the same number of elements. Set A has 4 elements, set B has 4 elements. Here we can write NA equal to NB. NA means number of elements of set A are 4 and number of elements of set B are 4. Therefore, A and B are said to be equivalent set. Number 5. Finite sets. Finite set. If I write set A 1, 2, 3, 4, 5, this, and another set B is 1, 2, 3, 4, 5. What is difference between these two sets? The elements of this set are countable. And how many they are? They are 5. And that's why this is known as finite set. This is finite set. And what about this set? The elements of this set are not countable. They are infinite. Therefore, this set is known as infinite set. This is infinite set. We can take some examples of such sets. Let set A X is such that X is a natural number. This set, I have written this set in which form? Set builder form. Can you tell me this set is finite or infinite? If I write this set into roster form, this will become A equal to 1, 2, 3, 4, like this. Now tell me, how many elements are there in this set? Infinite. And that's why this set is an example of infinite set. We will take another example. Let set B X is such that X is a natural number less than 7. This is also in set builder form. If I write this set in tabular form, this will become B equal to natural number less than 7. 1, 2, 3, 4, 5, 6. How many elements are there in this set? 6. They are countable, and that's why this is an example of finite set. Now, subsets of a set. What is the subset of a set? We can take one example. Let set A be the set of all students of principal. All students of principal. Set B be the set of all students of 11th class. Now see this set. This set is the set of all students of class 11th of principal. Class 11th of principal. Can you tell me whether all the elements of this set or all students of class 11, they are the students of principal also? It means all elements of set B are in set A, and that's why set B is a subset of set A, and we will write this as B is a subset of A. B is a subset of A, and symbolically we will write it B is a subset of A. This is the symbol of subset. Now what will be the definition of subset? If we have two sets A and B, and each element of set B is in set A, then set B is the subset of set A. Okay? Now I will write some examples. Let A be a set 1, 2, 3, 4, 5 up to 10. B is a set 1, 2, 3. C is a set 5. D is a set 3, 5, 9. And E is a set 5, 7, 11, 12. Now we will tell whether B is subset of A. Yes, because all elements of B are in A. What about C? C contains one element 5, and that is in A also. Therefore, C is also a subset of A. What about D? D contains 3, 5, 9, 3 elements, and they all are in set A. Therefore, D is a subset of A. What about E? E contains 5, 7, 11, 12. Here, 11 and 12 are not in set A. Therefore, all elements of E are not in set A, and hence E is not a subset of A. So here we can write A is subset of B. A is subset of B. Sorry, B is subset of A. B is subset of A. C is subset of A. C is subset of A. D is subset of A. D is subset of A and E. E is not the subset of A. We will write A is not the subset of A. This is the symbol of not subset of A. If E is not subset of A. So these are the subsets. Now how we write the subsets of a set and how many subsets are there in a set? Let us see. Let A be a set with two elements, 1 and 2. We will see how many subsets are there of this set. As we have studied about null set. Null set does not contain any element, therefore null set is the subset of every element. And second, every set is the subset of itself. See here, can I say A is subset of A? Yes, because all elements of A are in A. Okay, so first we will write the subsets of set A. The first subset is 5. The second subset will be 1. The third subset will be 2. And the fourth subset will be 1, 2. It means how many subsets are there? 4. Now let us take another example. B. This is 1. This is 2. 1, 2, 3. We will write all subsets. First is 5. Second is 1, 2, 3, 1, 2, 2, 3, 1, 3, and 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. How many subsets are there? 8. Here the number of subsets are 4. Or we can write this 2 raised to the power 2. Here the number of subsets are 8 and we can write it 2 raised to the power 3. And like this, if we have 4 elements in a set, how many subsets will be there? 2 raised to the power 4. It means 16. And therefore, the general formula will become if there are n elements in a set, the number of subset will be 2 raised to the power n. Okay. Now, what is a proper subset? Proper subset. See here. This set, this set, this. These all are proper subsets of set B. It means a proper subset is, let A be a set. A be a set. 1, 2, and 3. And B be a set. The number of elements in B is not equal to the number of elements in A. Such type of subsets are known as proper subsets. And therefore here, now we will see what will be the general formula to find out the number of proper subset. See here, how many proper subset will be here? 1, 2, 3. It means 4 minus 1, 3. And here 1, 2, 3, 4, 5, 6, 7. It means 8 minus 1. Therefore, the number of proper subsets will be 2 raised to the power n minus 1. So these are subsets, and if here these are the subsets of set B, if I write these sets in a curly bracket like this, now this has become a set, and this will be represented as PB, and this is power set of B. Set B is this. These are the subsets of set B. This is power set of B. It means what will be the definition of power set of a set? Power set is a set of subsets of a set. Power set is the set of subsets of a set. This was from my side today. Next will be tomorrow. Thank you.